Lesson 15.3, Task 1. All right, it says prove a Pythagorean identity. So remember the Pythagorean theorem, a squared plus b squared equals c squared, or side squared plus side squared equals hypotenuse squared. So we're going to use that to look at a Pythagorean identity. So when the terminal ray of an angle theta intersects the unit circle at point xy, then x equals the cosine of theta and y equals the sine of theta, and therefore the ratio y over x equals tangent of theta. Combining these facts yields the trig identity tangent of theta equals sine of theta over cosine of theta, which is true for all values of theta where cosine of theta is not equal to 0. All right, so if you remember in the last lesson, we looked at the unit circle and we discovered that x is your cosine and y is your sine. We also looked at tangent as being opposite over adjacent, which therefore creates tangent of theta equals sine over cosine. All right, so the following task derives another identity using the Pythagorean theorem, which is why this trig identity is known as the Pythagorean identity. In the figure, angle theta is drawn with its terminal side intersecting the unit circle at point AB. Drawing a vertical segment from the point down to the x-axis creates a right triangle. All right, so this is similar to what we looked at before. All right, so remember this is your initial side, this is your terminal side, and we've rotated up counterclockwise, which is in the positive direction because this is in the first quadrant, and this is our angle theta. So whatever our angle theta is, we have a side, and a hypotenuse. So we can use the Pythagorean theorem here. This point on the circle is AB. So if you were graphing this on graph paper, whatever this distance is, you would go over and up just like you would on graph paper to determine what this point AB actually is. All right, so how are the lengths of the legs of the right triangle A and B related to the value of theta? All right, so remember A is your cosine and B is your sine. So A is the cosine of theta, B is the sine of theta. All right, so it says explain how you determined your answer. A is the length of the side of the triangle adjacent to theta. Adjacent just means it lies beside of theta. So here's theta. This is adjacent. This is opposite the angle, and this is the hypotenuse. All right, B is the length of the side opposite angle theta, and the hypotenuse is 1 because we're looking at the unit circle, and you can see that they have designated that this is 1 unit. All right, since the circle is a unit circle, all right, so blank and blank. So A is the cosine and B is the sine. So it's just kind of explaining why it is that way. All right, now that the right triangle has been created, the Pythagorean theorem can be used to write an equation relating the lengths of the sides of the triangle using expressions for the lengths determined in Figure 1. This leads to an equation relating the sine and cosine functions. All right, so looking at the image here, we've got A, and we've got B, and we've got C if we're talking about Pythagorean theorem. So we would have A squared plus B squared equals C squared. All right, so that is the Pythagorean theorem. So it says, how would you justify the steps shown? All right, so after that, you could substitute, instead of A squared plus B squared equals C squared, we could say cosine squared plus sine squared equals 1 squared. So that would just be substituting in for A, B, and C. All right, and then all we're doing from here to here is just simplifying. So this squared plus this squared equals this squared. So 1 squared is just 1. And then you can move the squared term inside or drop the parentheses. So that is just a simplified version of the Pythagorean identity. So we got the Pythagorean theorem, and that leads us to this Pythagorean identity that we're going to use. All right, in the final step, notice how the power of a trig function such as cosine of theta, quantity squared, can also be written without parentheses. So these two things are equal or equivalent because theta is just an idea. It represents an angle, but we don't know what that is right now. So we're just going to say whatever that is, we're going to square it. So the final step of the calculation above is typically written as sine squared of theta plus cosine squared of theta equals 1. Which algebraic property justifies rewriting the equation in this form? All right, so to go from cosine squared plus sine squared equals 1 to sine squared plus cosine squared equals 1, what we're doing is reversing the order of these two things. And when we do that, that's called commutative property. If you have two things and you change the order, you're using commutative property. Remember, associative property usually has three things, and again, grouping them in different orders to do them in a different order would be associative property. And then the identity property is just when you multiply something by 1 to get itself back. That is the identity. All right, that's all for task 1. If you have any questions, let me know. Lesson 15.3, task 2. Find the value of trig functions given the value of sine of theta or cosine of theta. By rewriting the Pythagorean identity, you can express both sine of theta and cosine of theta in terms of the other. Each version involves both positive and negative square roots. The sine is determined by the quadrant in which the terminal side of the angle of theta lies. All right, so here's what we're saying. In the last task, or the last example, we looked at where the sine of sine squared theta plus cosine squared of theta equals 1 came from. So this comes from the Pythagorean theorem, and we use the Pythagorean theorem to show or prove the Pythagorean identity. Now they're saying if you take this and you solve it for each of the two trig functions, then you can get three different ways to look at the Pythagorean identity. So if we solve for sine, you're going to subtract cosine squared of theta and then take the square root of both sides to get rid of the squared term. So sine of theta equals plus or minus the square root of 1 minus cosine squared of theta. This is equivalent to this right here. It's just solved for sine. Same thing if we solve it for cosine. If you solve for cosine, you would subtract sine squared of theta and then take the square root of both sides. Okay, remember when you take the square root, you get a plus or minus. So the Pythagorean identities can be written in these three ways. All right, it says given the sine of theta equals 0.434, where theta is between 0 and pi over 2, find the value of the cosine. All right, in what quadrant does theta lie? All right, so this is telling us which quadrant it lies in. Remember, this is in radians. So think about what this would be in degrees. Pi over 2. So we know the whole unit circle is 2 pi. We know that 180 degrees is pi. So half a pi would just be 90 degrees. So if it's between 0 and 90, that means it's in the first quadrant. All right, if this said pi over 2 to pi, then it would be in quadrant 2. And then, so on and so on. So if it went from, say, pi to 3/2 pi, that would be third quadrant. And if it went from 3/2 pi to 2 pi, then that would be in your fourth quadrant. But again, this just determines your domain. This tells you which quadrant you lie in. All right, so complete the solution. So the cosine of theta equals plus or minus the square root of 1 minus sine squared of theta. So that's just the formula. That's how we rewrote up here. We rewrote the Pythagorean identity, and that's what we did. And we can use that to find this value. So I can take my calculator and plug it in. and I'm going to plug in the value that they ask us to find, which is right here, 0.434. So if I plug that into this equation, then I'm going to get this answer. So if you use your calculator, all right, we can do square root, and we're going to do 1 minus, and I'm going to do 0.434, and I'm going to square that number, and I'm going to hit enter, and it's going to give me approximately this number here. Okay, now you know it does say plus or minus. If I do this in the calculator, I know that it's still going to have a plus or minus answer there. And it has the squiggly lines because it means it's an approximate answer. We had to round it. It's not exact. Okay, all right, so how would sketching the triangle help you choose the correct sign here? All right, if you sketched it, then it would tell you which quadrant it's in, and it would help you determine what those signs are. Since the value of the cosine function is positive in quadrant 1, we know that the cosine will be positive. All right, so again, remember we determined from this here what it was, and we know that it is in quadrant 1. So the sine and cosine create the ordered pair. Cosine is your x, sine is your y, and that gives you your ordered pair for a point. So this ordered pair would then create a point on your unit circle. Just remember, all points are not exact. Like we looked at the 30, 60, 90 and the 45, 45, 90 first, but now we're looking at other points that are not specific to those. So these we have to look at, sometimes using a calculator or other methods. All right, that's all for task 2. If you have any questions, let me know.